Note the formulas at the top. If x and y are independent, then the variance of x plus y will be what? Variance of x plus variance of y. And the variance of x minus y will be the variance of x plus the variance of y. Good. So if they're not independent, okay, if x and y are not independent, then we have a covariance term. So take note of these formulas. Variance of x plus y is variance of x plus variance of y plus 2 covariance xy. And variance of x minus y will be variance of x plus variance of y minus 2 covariance xy. This formula, I've said it before, variance of ax is what? A squared variance of x. Good. Notation wise, I think you have seen this before, right? We use this notation for the expected value of x. The expected value of x, the mean of x, we like to use mu. And let's say we have the pth percentile, right? The pth percentile, let's call it x sub p. I'm just going to call it xp, right? So xp will be what? Probability x less than or equals to xp will be p%. That's it. Okay. So the pth percentile, this is an easy, if you call the pth percentile x of p, then the probability x less than or equals to xp will be just p%. Great. A reminder, we know the median is the 50th percentile. We know that, right? Which is x sub 50. Also, the mode, right? How do you get the mode? We are dealing with a continuous random variable. To get the mode, we have the PDF with us, the probability density function. What do? You take the derivative of that, you set it to 0, and you find the value of x that makes the derivative equal to 0. What I mean by that, you have f of x, then we have f prime x, and what do? You set this equal to 0 and solve for x, and that will give you a mode. So I've written here where fx is maxed, okay, the maximum. All we have to do is do this, like I just said, and we are done. Okay, quite easy to do. And anytime you want to find the kth moment, right? That means if you want to find the expected value of x cubed, is just like the way I said earlier. You have x cubed fx dx, integrate using the right limits. That's it. Okay, good. So let's look at this example here, and give me a second. I'll move this up a little bit. Okay. So we are given, right? Let's see. We're given this density function, 2.5, and then I have 200 raised to 2.5 over x to the power of 3.5, and you're told x is bigger than 200. You're told, okay? That's your PDF, defined for x bigger than 200. So you're asked to find the 30th percentile. The thinking is more important, right? Who cares whether it's 30th or 40th or whatever? All we're thinking of is this, right? xp will be equals to p%. So in our case here, it is 30th percentile. So the probability must be 0.3, right? Probability 30%, right? 0.3. So this is an integral, right? So we are stopping at xp, as you can see. What will be my lower value? Be careful, it's not negative infinity. What is it? 200. Yeah, because that's the smallest value x can take. So let me clear this first. This is the most important part. Be a bit careful. We are taking an integral and we are equating. When you take an integral in continuous random variables, we are evaluating probabilities. Yeah. So when you're evaluating expected values, then you have another x term, or if you're trying to find expected value of x squared, you have an x squared term. All of those will be in front of the PDF. So here, no such thing, just the PDF, right? So plug this in, okay, integrate with respect to x, equals to 0.3. The integration is a very simple integration, right? You can go ahead and do it any way you like. I've done it here for you, play it up a little bit, and you'll get, don't make numerical mistakes, right? I'm not going to go through this solution with you. You work it out, you'll get your XP as about 231, right? Here you go. Okay, 230.67. So I wanted to point out this idea to you, okay? This one here, and just be careful with the integration and the plugging in of the numbers. One more quick example, which I would like you to do it, which I would like you to do it yourself. Okay, one quick example for you to do yourself. Let's just read it. I have the solution on the next page, so there's nothing for you to worry. Okay. We have, let's see, an insurance company. Let me look at my sheet of paper, right? An insurance company policy reimburses dental expenses up to a maximum benefit of 250. So, okay. The maximum benefit is 250. The probability density function they gave me soon, right? Once we talk about some specific distributions, you'll recognize this straight away as an exponential distribution. Yeah, this is the PDF for a exponential distribution. Okay. Very soon you'll see it straight away. It's lambda e to the power minus lambda x. Okay. Now mind about this. The formulas you will learn slowly. Okay. This is a classic exponential distribution density function. Yeah, lambda e to the power minus lambda x. Okay. Some people learn it like this: 1 over mu e to the power minus 1 over mu x. Either way. Good. So when you deal with a PDF like this, okay, let me tell you all the general things first, right? When you deal with a PDF like this, the exponential distribution, you will know soon that this one here, your CDF is what? 1 minus e to the power minus lambda x. Not a big deal, right? I can quote this to you because, you know, I teach this on a regular basis, but if you have forgotten it, so what? And if you don't have a formula book, so what? Just go and do the integration, right? Just go ahead and do the integration and you will get your what do you call it? Your CDF. So now that we know that, this one here, they tell me C is a constant. You can tell, right? Okay, C is a constant. Calculate the median benefit. So just a few things, right? If they reimburse dental expenses up to a maximum benefit. So, which means if, let's say, if X is less than 250, you will get X, okay? If X is bigger than 250, then you will get 250. Just an idea, right? It's what we call deductibles and all those things that you learn in an insurance course. But never mind. I'm just telling you what, by right, I should introduce a new random variable X1 or Y or something. I didn't do all those things. I'm giving you an idea, right? If your claim is below 250, okay? If your claim is below 250, let's say your claim is 40 bucks, they'll pay you 40 bucks, okay? And I'm talking about expenses here. Right? I use the word claim, but never mind, okay? Dental expenses, right? If it's, let's say, 40 bucks, they'll pay you 40 bucks. But if it's 300 bucks, okay? If it's 300 bucks, how much will they pay you? Good. They'll only pay you 250 because that's your maximum, yeah? Okay. So now that you know that, we are trying to find the median benefit for this policy. So median, remember, we will have very quickly. Remember this? That's it. That's your median, right? So we can write 1 minus e to the power minus point. How many zeros are there? 0, 0, 4, x. Let me use the word, let me use the letter xm, right? That'll be equals to 0.5. That's it. Okay. So this thing here, right? 0.004 xm, and that's be equal to 0.5. Now you need to solve this though. You need to work this out and do that, and you'll get a certain value. It's about 173 if I remember correctly. Okay. So the important thing is this thing. Okay. When you have a median, we have got is how much? 0.5. So just clean this up. This is a simple equation to solve for us mathematicians. You solve it and you'll get 173.28.